Good afternoon. Good afternoon, good morning, good evening, wherever you are. My name is Karma Yangzom. I'm the Principal Environment Specialist working in the Sustainable Development and Climate Change Department of ADB, and I will be moderating the webinar today. So to get us started with Module 2 of this training or webinar on the Modern Road Ecologist Toolbox, we will have Ms. Shani Campbell, who will open the module. Ms. Shani is the Country Director of the Tajikistan Resident Mission. She is leading ADB's operations in Tajikistan and supervising the formulation and implementation of ADB's country partnership strategy, which will support the country's national development goals and reforms. Shani joined ADB in 2010 from the private sector. She has 26 years of experience in 26 countries in the transport, energy, agriculture, water resources, and finance sector. Prior to her current position, Shani also held the position of Principal Transport Specialist and Deputy Country Director for the Afghanistan Resident Mission. She has a master's degree in development and a bachelor's degree of science from Victoria University of Wellington in New Zealand. So Shani, I invite you to please give the opening remarks for this webinar. Over to you.
Thank you very much, Karma. Good afternoon or good morning or good evening, everyone, depending where you are. Welcome to Module 2 of the training on the Modern Road Ecologist Toolbox. I understand the first module was very well received by the audience, and I'm sure it will be the same for today. With the ongoing pandemic and heightened dependence on IT tools for professional and personal reasons, this training on online tools and resources is a very topical one. As most of us here today would agree, life has to go on despite the pandemic. Development cannot stop. In fact, with the negative economic impacts of the pandemic, it's critical that we work harder to boost local economies. National governments, excuse that. With the national economic impacts of the pandemic, it's critical that we work harder to boost local economies. National governments need to continue with their development agendas, and we in ADB and other multilateral and bilateral financing agencies need to provide stronger financial and technical support to our developing member countries. Infrastructure construction is seen as one of several ways to boost local economies. While this brings many opportunities for employment and income generation, it also brings greater risks, particularly for social and environment safeguards. In the rush to restart local economies, the likelihood of relaxation of environmental and social regulations and inadequate safeguards due diligence is much higher. And in fact, this is already happening in some countries. However, this doesn't have to be the case. With recent advancements in digital technology and data availability, it is possible to design projects and conduct environmental and social safeguard assessments in a much more efficient manner. The focus of today's webinar is on managing and analysing biodiversity data using digital platforms for designing ecologically friendly roads and railways. Such types of tools are particularly important in Asia, where there are still significant needs to construct new transport infrastructure and improve existing ones. Asia comprises just 14% of the Earth's total land area, but supports almost 4 billion people, or nearly half the world's population. The average human population density is about 10 times higher in Asia than the global average. Hence, infrastructure needs are amongst the highest in Asia. While infrastructure construction can cause significant social and environmental impacts, it also brings huge opportunities for countries to build ecologically friendly and climate resilient infrastructure. That is why we need to promote digital technology and online toolboxes such as those that will be demonstrated today. These tools are an important step for bringing us closer to smart and sustainable infrastructure. I look forward to seeing the training today, and I invite all the participants to actively participate. Thank you, and back to you, Karma.
Thank you, Shani. Thank you for those very inspiring words. So we will move on, and I will first quickly introduce our three resource persons for today. I assume that some of the participants today also attended module 1, but we may have some new participants. So still, let me again introduce our resource persons, Tony and Ben. Tony, or Dr. Anthony Clevenger, he's currently a senior research scientist at the Western Transportation Institute in Montana State University. Over the last 25 years, his research has focused on developing science-based solutions for conservation of landscape and animal population in areas experiencing expanding road systems. He has published his research findings in over 80 articles in leading international scientific journals and co-authored 3 books on road ecology. He has served as a principal investigator, planning, designing, and evaluating the use of wildlife fencing and crossing structures in projects in Canada, the US, and several other countries throughout the world. Our second resource person for today is Benjamin Dorsey. He's an environmental scientist and spatial data specialist. He works for Parks Canada as an ecosystem geomatics technician working on mountain goat and caribou projects. He has studied the impacts of railways and roads on wildlife for the past 14 years. His career has focused on developing solutions to ecosystem and transportation challenges by applying GIS technologies. He has worked with the China Academy of Transportation Sciences and in a number of other countries throughout the world. Last but not the least, our third resource person is Bonaparte Masangai. We can call him Bon. So we had Ben and now we have Bon. Bon is a geodetic engineer with strong technical background in surveying, remote sensing, photogrammetry, GIS analysis, and data analytics. His experiences as a geodetic engineer include being part of the survey team that surveyed the Galok oil field in the seas of Palawan, the PTT oil field in Thailand, vessel positioning in the seas of Vietnam, and data analysis in Singapore. As a GIS specialist, Bon has trained national and city governments on the use of GIS, its application in tax mapping, land use planning, climate change, and disaster risk reduction. Aside from ADB, he has also been engaged on several projects of the World Bank, USAID, and AusAid DFAT. He is currently the GIS focal and administrator of SPADE, which is a web-based GIS tool within ADB. And Bon will be talking to us and running us quickly through the SPADE tool. So let us get started with the presentation for today. Can I invite you, Tony, to start with the first presentation?
Yes, thank you, Karma. Let me share my screen. Let's see that up there. And I think we're ready. Everybody see that okay?
Yes.
Great. Thanks everyone for attending this second module on web tools for the Modern Road Ecologist Toolbox. We had a lot of good feedback from you in the first module, and I'm sure we'll have a lot of good discussion in this one because we're really going to get into the nitty-gritty, the details, and actually get our hands dirty and talk about how these web tools and platforms can be used in a real practical way. In this module, we'll provide an example, a case study from how these tools have been used in meeting the objectives of a biodiversity baseline assessment on an ADB project, and also include a demonstration that Ben's going to provide in the second presentation here in this module. We hope that this will help you show how these tools can be used and data can be displayed, data can be shared in an ADB project. And for you, those of you out there that perhaps don't work just in environment, but more in social or cultural areas, these tools might provide some ideas for you to help make the work that you're doing for ADB projects more efficient and streamlined also. Projects with perhaps a social monitoring objective. Let's see, okay. All right, I'm just going to go over quickly some of the, for those of you that weren't attending the first module, but we live in this era that's called the Anthropocene because our activity as humans really dominate what's happening, particularly with regards to climate. And as a result of this, biodiversity is declining at an unprecedented rate and also scale, and causes for that decline are the loss of habitat and continued fragmentation of remnant habitat that wildlife need or are dependent on for their survival. And we lived on a paved planet. We might include railways in here too, but we talk a lot about roads and highways. And today there are 12 million kilometers of roads on the planet, and in the next 25 years, we're going to see that double to another 25 to actually 25 million new roads on the planet. And about 90% of these transportation projects are going to be taking place in developing economies. That is to say, Latin America, Africa, and Asia. And these are areas of some of the most important biodiversity hotspots on the planet today. And it's extremely important that we protect these most remote areas from the impacts of transportation infrastructure. So today I'm going to talk about a case study. This is a project an ADB project which we are involved in Nepal. It's the stretch of highway between Narangat, Hetauda, and Pathlaya. We call it the NHP project because it's just much simpler to call it NHP as opposed to the three cities that link this highway. Smart infrastructure planning and design to protect natural habitats and biodiversity. It's a SASEC road improvement project. The funders are the government of Nepal and ADB. It's situated in this very important conservation landscape, the Terai Arc landscape in Nepal. And there's actually two roads. There's what we call the NB, Narangat to Butwal, which is west of the NHP road. This is 115 kilometers. It's a bit more advanced. It's the baseline biodiversity assessment has been completed. Construction has actually started on that stretch of highway. It's probably about a year or two ahead of the NHP project. And the project that we'll be talking about today is again, this NHP, which is the Mahendra Highway. It's about 108 kilometers. And this is actually in progress. It started we had the inception meeting in November of 2019. Field work started shortly after that, and we completed field work on this project in February of 2021. So it's an existing highway, the Mahendra Highway, the East-West Highway, and it's going to be upgraded from 2 lanes to 4 lanes. Traffic volumes are extremely high. Traffic is congested, and the reason that this is a Category A project is because there are IUCN red listed species. This is an important conservation landscape at a regional scale. It's adjacent to the buffer zone of Chitwan National Park and also Parsa National Park. So just to situate this project, as you can see here, Chitwan and Parsa National Parks in dark green. We have the buffer zones in yellow, and you can see, well, the NB road. I'm not sure if you can see my cursor on the left-hand side in Butwal to Narangat. This is the section of highway which is actually starting construction right now, and then Narangat to Hetauda, then down to Pathlaya, close to the Indian border. So this is an important landscape, as I mentioned earlier. Not only the national park, but the buffer zone is managed for wildlife conservation. And the important aspects here are to maintain connectivity of wildlife populations across this highway to the north into the Churia Hills. This is also important habitat. It's not a national park, but it's also important habitat to maintain wildlife populations, particularly these wide-ranging species such as tigers, leopards, and other species which have these large area requirements for survival. So the objectives are really twofold: to conduct a comprehensive and in-depth ecological studies. So really getting into collecting at least 1 year of data that will cover the different seasons of the year, intensive field work, and with that information, provide technical support for the guidance and design of mitigation of that highway, of the impacts. So what are the impacts? The impacts is obviously from this highway expansion, not that there's enough highway or traffic volume at the moment, but there's going to be a lot more when this highway is upgraded to 4 lanes. It's going to be wider. It's going to occupy more habitat. So we have not only the increased traffic, but also disturbance from the vehicles on this highway that can disrupt animal movements. And with that, we have potentially mortality of wildlife crossing the roads, trying to cross the roads, and also disrupted movement. So fragmentation of habitat and severed populations, which eventually, if we don't have these important connections between these populations that are subdivided by a highway, eventually these populations will disappear. So the project is being conducted by 2 teams, by 1 team actually, but it's 2 different companies in Nepal. As Jade Consult, which is located in Kathmandu, and on the international side we have ESSA Technologies based in Vancouver, Canada. So the objectives of this project are more than just the biodiversity, which I'll be talking about here today, and how these web tools are being used, which Ben will talk about later, but also delves into bioengineering, cumulative effects assessments, climate change, looking at natural capital, ways of getting natural capital into the local communities. And then there's a training and also a knowledge product at the end of this project, which will actually be completing in November of this year. So what type of data do we need to collect, and what are these impacts? Well, we know that it's mortality, as I mentioned earlier, from vehicles, and it's important. We need to maintain habitat connectivity or population connectivity for these wide-ranging species that need these large areas to survive. What species are we considering? Well, when we start a study like this, we oftentimes there's a focal species, but at the same time, we need to think about more than just one particular species, but we need to think about possibly ecosystem indicators or multiple species. Do we just focus on the umbrella species such as tigers, or a big charismatic species such as Asian elephants? Do we focus on multi-taxon, so large species, medium-sized species, small terrestrial vertebrates? How can we use all of these species data that we're collecting to help inform mitigation on this project? And while we've been conducting this work, we actually came across a paper that was published in Animal Conservation, which we're going to actually apply in this project. We don't have time to go into a lot of details in this module, but for those of you that are interested in this paper in Animal Conservation, it was a study that was conducted by Aditya Gangadharan in the Western Ghats. And he actually collected data on about 20 different species, but he was able to, through a principal component analysis, identify clusters of species and how similarly they were with regards to habitat. And just to read you part of it, some of the results, he found that lion-tailed macaques and tigers were strongly associated with closed forest and low human disturbance, but elephants, sloth bears, and gar were more tolerant of anthropogenic impact, and sloth bears and gar preferred open forest and grassland. So we can't just rely on an umbrella species, because we have a lot of species that have different habitat requirements and different tolerances to human populations. And from this, he found that protecting flagship species or umbrella species would only protect species with similar habitat preferences. So a really interesting paper, a really interesting approach that he's used, which we plan to use with all of this camera data, which we'll show you later here in this module. So we've, as we proposed in this study before it began, we really wanted to identify three focal groups: the species of conservation concern, so IUCN enlisted species that you see here. Again, these are sort of the, the iconic or the most charismatic species that we know: the tiger, rhino, elephant, leopard, etc. And then we also want to focus on the canopy dwelling species. And this, in our study areas, the Terai gray langur. These are important because these are often overlooked in biodiversity baseline assessments, but arboreal species are highly impacted by transportation infrastructure projects because they lose that connection within the canopy. And last, small and medium-sized vertebrate species. So with all this, we're trying to have these indicators, these within species and ecosystems. We're using tools and these technologies, which you're going to hear about, which you heard about last week, and we're going to hear about more today, and also a week from now in Module 3, to meet the goals of this ADB project. So how do we begin? Back in 2019, well, we know that the study area here is the NHP highway. So we basically took the western end, which was Narangat, and the opposite end, which is Pathlaya. And because we're studying a primarily, well, as part of our study objectives, we have these wide-ranging carnivores, tigers, for example. We need a relatively large study area around this highway. So we've taken a 30-kilometer buffer and we've drawn that around this highway, and that's what you see here. This is really the outline for our study area where this work is going to take place. And as I showed last week, you've seen this, but it just shows you the different methodological tools that we're using for the different types of data that we're collecting. The roadkill surveys, camera trapping, bird surveys, sign surveys, which are done with the camera trapping. And also we're monitoring animal use of existing culvert bridges that are out there. These are bridges, culverts and bridges that during the reconstruction of this highway can be designed in a way so they accommodate not just the hydrological needs, but also the needs of wildlife and also aquatic organisms. So roadkill, I'll go through some of the data collection methods here. Roadkill surveys, these are conducted 5 times a week. These began in shortly after not long after the project, the inception report was submitted. We have 2 field crews, 1 in Chitwan on the west end of the project, as you see in the map on the left, and then also 1 in Pathlaya, the area in green. So each of these teams, these 2 teams, have divided up the work. The one from Chitwan covers the area from Narangat to Hitauda, and the one from Pathlaya covers the stretch of highway from Pathlaya to Hitauda. They record live road-killed animals, and also we want to have them record observations of live animals, that is, animals that are on the side of the road, that are near the road, that are observed in the road corridor, and also crossing. And secondly, we wanted to also collect information from using local knowledge, and that was to consist of visiting locals in settlements in these key areas that we're going to focus on, which I'll show you later, areas of intact habitat, and to find out what additional information we can collect about animal roadkill, animal observations, and animal crossings. Here I want to talk about the existing culvert and bridge monitoring. We've identified, we looked at all the different size culverts and bridges that were underneath the highway in these areas of intact habitat. And we have the 2 teams which are conducting the roadkill survey check these existing culverts and bridges while they're doing the roadkill survey. And on the map on the right, you can see all the different culverts and bridges that we identified that we wanted to monitor for wildlife use. And this would provide us information on not only what species are present in this area and potentially using these structures, but also how we might be able to retrofit these bridges and culverts to increase wildlife use underneath the highway. Now, this part about the cameras and the sign surveys, were conducted as the team checked the cameras. So these are basically walking transects from the road to the camera, noting sign. So what I want to show here is how we determined what sections of highway to focus our cameras and sign surveys. And the criteria was that we wanted this needed to be in intact and connected forest habitat. That is to say, really critical habitat linkages at a large scale and also a small scale. What I'm showing you here, the blue circle on the left is a very important, as you can see, large scale habitat linkage and corridor as it extends way up into to the north of the highway into the Churia Hills and also south into Chitwan National Park. As you go to the right, the second one on the right is also an important large scale linkage, but we also want to be able to monitor and collect information from species that are present in some of these smaller linkages. As you see this third blue circle on the right, this is an example. Perhaps wide-ranging species, this may not be so important because they basically come to an ecological dead end south of the highway. There's no way they can go because it's all developed in farmland. But for small and medium-sized terrestrial vertebrates, this type of habitat is important. So this was some of the criteria that we used to identify where on this highway and what types of habitat we wanted to focus the camera trapping and the sign surveys. And of all these in our these corridors and these critical linkages in our study area, this is, as you can see, Baratpur right there, or Narangat. This is the bottom of our corridor. This is really one of the most important, probably the most important wildlife corridor in our study area. As you can see how it connects Chitwan National Park to the south, through the buffer area to the Churia Hills in the north. This is about a 4-kilometer section of corridor that is bisected by the Mahendra Highway. And in terms of camera trapping, in each of these study areas, these sub-study areas, this is our how we displayed our cameras. We had alternating 600-meter, 300-meter distances where we placed our cameras from the road. We had roughly 20 to 25 cameras. We had cameras set out for 20 days at a time, and then we moved them to another sampling area for a total of 88. Well, we did this during the monsoon and also during the dry season. It took about 2 to 3 months to finish each season camera sampling. And in total, we had about 82 sites. Oops, let's see what happened here. No. There we go. Okay, so camera trapping, this just shows you some of the setup and the programming and the training that took place with the field assistants. This shows you the different sub-study areas or sub-sampling areas that we focused on. The B is the Barandabar corridor. This was one sampling session. We put all the cameras in there. We ran them for 20 days. Then we moved them to this section with the L and the M, Lotar. And we ran that for 20 days. And then the R and the AM section. And then finally the Pathlaya section. So we have a lot of photographs from all this. We use time lapse to classify all the photographs. This is all the data that's I think we'll go over some of this in the later on in this module, some of the forms and some of the information that's collected from time lapse. And then this is uploaded into our platform. And as expected, we were able to detect some of the species which we expected to be in the area. We knew were in the area, such as tigers, yellow-throated marten. But when we do these studies, these camera trapping studies, they're extremely important and valuable, not just for the specific project, but also for natural history and conservation of wildlife species in general. For example, we unexpectedly had photographs of honey badger and crab-eating foxes. There was only, I think, one other record of an observation of both of these species in Nepal. So these were relatively rare species regionally, and they were detected from our camera traps. One really bonus was that we were able to take advantage of, we were able to access, get permission to use the NTNC data from the National Tiger Census. This is a camera trapping survey that was conducted in Chitwan and Parsa National Park at a very small scale resolution, 2.5 by 2.5 kilometer cells in the national parks, and then outside the national park at a 15 by 15 kilometer cells. All the camera trapping data that was collected within our study we're able to use that in this ADB project. And that's where we plan to use this multi-species clustering approach to see where are the most important linkages, habitat linkages for a variety of wildlife species in our project area, not just tigers and elephants and rhinos, but some of the smaller and medium-sized terrestrial vertebrates as well. So that was a real bonus. There was a lot of data there, more than 5,000 species detections, 11 species with endangered, vulnerable or near threatened status on the IUCN list. So it's important to be able to really dig down and inquire and find out what other additional data may be in the areas where you're conducting these biodiversity baseline assessments, to take advantage of existing data that might be able to supplement the work that you're doing as well. And the important thing is to be adaptable to these changing conditions, changing environments, and these things that just aren't predictable, such as the COVID-19 lockdown, which certainly affected our project, or other events that are beyond our control. We were able to collect a fair amount of roadkill data from December 2019 to January 2021. We weren't able to collect any local observations using the local people. That was unfortunate. The camera surveys, we were able finally to collect all the sampling data that we needed from the dry and the wet season. It did take a little bit of time and some postponing, but we eventually got it all finished. The bird surveys were completed, and the underpass monitoring, only a few sessions were completed before the COVID lockdown. So unfortunately, we weren't able to collect much from underpass monitoring. However, I think that this list of different survey methods are quite strong and provide a lot of information for road projects and rail projects that are assessing biodiversity prior to construction. So how do we decide on web tools and a dashboard for our NHP project? This is actually our website. We knew that data collection apps are regularly used today, as of almost 10 years ago now, with cell phones. They're very efficient. Everybody has a cell phone, so it's quite easy to have these apps. So it just started out that I asked Ben. I've worked with Ben for a long time and knew that he could develop these things quite simply and a lot better than I could do it. And the fact that we are an international team on this project with field assistants in Chitwan, others in Pathlaya, Our Nepalese biologist lead, Bhuvan Sharma, is in Kathmandu. I'm in Canada, Clara Grilo's in Portugal. We're all spread out, and we need to have a simple measure or a simple means of everybody being able to access the apps and the data that's being collected, and being able to quickly summarize and display this information in real time. And as you see here, this 826, this is the number of roadkills at that moment of the project. So anytime the roadkills, if the next day the roadkill survey was conducted and there's another 10 roadkills that were collected, that information would be automatically uploaded and it would reflect 836. So we developed this Nepal Road Ecology Project website, and then eventually realized that this could function as a data platform for the biodiversity baseline assessment for the NHP project. And we feel that this is really a nice model and could be a model for other projects as well. The NB project, which is in the during construction phase right now, is going to be using the apps which we showed you last week, and you'll learn more about those apps here tonight or today. So that's the end of my talk, and I think Ben is going to provide us now with a demonstration. Let's see, let me stop my sharing.
Thank you, Tony. Before we move to Ben, perhaps we can take one or two questions.
Sure.
I think it's related to this part of the presentation which you just completed. There's a question from Fook. How do you scope the study area?
Well, it really depends on what you're, what species you're focusing on. And in our study area, obviously, Chitwan Parson National Park, we're talking about Asian elephants, one-horned rhinoceros, leopards, tigers. So these wide-ranging mammals, terrestrial mammals, which require large areas for their survival. So that's how we decided on a 30-kilometer buffer. Knowing the average home range size of tigers of some of these species, we also wanted to be able to include the Churia Hills to the north, the national parks to the south. It could have been 40 kilometers, it could have been 50 kilometers. 20 kilometers is probably not large enough, but we settled on 30 kilometers, and it's really a matter of scale, a geographic scale. It really depends on what species you're focusing on.
Mm-hmm. So basically the species, and I guess understanding the local landscape.
Their movements and the population sizes and densities, yes.
Mm-hmm. And then I see some more questions, but perhaps this is more in relation to what Ben is going to talk about. It's about the app. And I think Ben is already answering some questions, but perhaps for now we can shift to Ben's presentation and demonstration, and then we can take some of these questions, or perhaps the questions will get answered while he's doing his presentation. Okay. So Ben, over to you.
Okay, thank you, Karma. Yes, these questions are perfectly relevant, and we'll answer them through the course of the conversation here for the next 40 minutes. Thank you all for attending. It's a pleasure to see so many people interested in this topic. Picking up where Tony just left off, I'll share my screen just for a moment or two before we go into some demonstrations. So tonight we're going to talk about the website Tony just introduced. I'm going to go through it in some detail just to help you understand how easy it is to create a website like this, to bring an international team together and to share live data. Then we're going to, after we demo the website, I'll go into the data collection apps and the dashboard and spend about 15 minutes here. Before I do that, I'll just point out a few things. We have added some links here for questions that have come up during the webinar already, and I'll be posting a few more as we move on through the evening. The webinar's website, as well as Nepal's website, are both built using ArcGIS's hub technology. It enables you to build a website rapidly and integrate it with GIS data that you've posted online. Please go here. We'll talk a little bit more about it in a bit as well. So here's our website. This is the live version on the internet. The site is password protected. It contains several data sets that are live. Work is still ongoing on this project. And so similarly to the some of the things Tony was pointing out earlier, the information on here is dynamic. We initially started using this to essentially help our field workers access the data collection apps that use Survey 123. And we provided them with these QR codes so they could go into an office, use their cell phone, and simply take a picture of the QR code to load the app once they've logged in. The website shows a few simple live data sets that they collect with the data collection apps. The most obvious being the roadkill data. So across the top of this website are the main tools for our team. The first is a Data Explorer app. The app is quite simple. It helps you see some of the initial value of sharing and storing data this way. In addition to showing you the app itself, on the left-hand bar are the information about the app, because we have several, and this is a quite simple one. The information on the left shows you when it's been updated and who it's shared with. And that's an important aspect of building apps and dashboards, is some of them have the goal and the purpose of communicating maybe to a larger team or even out to the world at large. However, some of them we maybe only want to share within our organization. If I keep moving across the top banner here of this website, then the next link we have here is for Google Drive. We use Google Drive here simply to share information and to store temporary files or project working files. You may use Microsoft OneDrive or Dropbox or whatever tool. What we're showing here is how we've rapidly built something to enable our teams to work both in the field and in the offices, maybe in different countries, and to share information. So part of that, in addition to Google Drive, is creating an online data catalog. This is both data we've published through maybe GIS analyses, or we've curated it. Someone may have shared the data with us, or we may have collected the data ourselves. Obviously, the roadkill and live observations. Here on the bottom right, you can see the camera sites data set. Different members of our team use these data for different reasons, and they may even use different pieces of software to access them. So the website gives them the ability to see the data, to edit it, maybe to filter it to only see certain sites, or to download it. And for this particular data set, this is the most obvious use here. maybe if you're using QGIS or Google Earth, you might want to download these data in a different format. I continue on to show you a few of the bits of functionality here. The next one is a live data editor. As data come in and are collected through the field apps, maybe some of them are incorrect, or there's a location error, or there's an attribute error. So the data editor app allows us to correct those edits. It also allows us to do things like inspect the attached photographs to confirm a species identification or confirm other aspects of the attributes. This is a tremendous tool. It saves a lot of time. It also enables us to collaborate on the information as it comes in. So the data editor actually allows us to edit data that was initially collected on a mobile device in the field. It lets us do a lot of other things as well. One of those things up in the top right-hand corner of your screen is simply to draw on the map. It's a useful tool. Often we need to discuss a point or a region and send information back and forth. And maybe we need to move a camera trap, or there's some other work that needs to be done there. Being able to draw on the map is, a very simple thing. In addition to that, we have a whole host of tools that we've added to this app. And there are others. These are the ones that are most useful for our purpose. So we can add other data within our team. We can add data that's found publicly available online, or we can add a file that we might have on our own hard drive to compare how that information lines up with what we can see on the web app. So you can see here, you can upload a shape file or a KML file or a GPX file. A GPX file is a file format typically associated with a handheld GPS. There's a lot of functionality you can build in these, and I'll demonstrate a little bit of that later. Clearly here we also have some other layers that we could turn on and off as we look at these data. Obviously, there's the standard functionality we're all familiar with, things like changing the base map, looking at the legend, etc. One of the last things I'll point out here that has turned out to be quite useful is the ability to print out this map. So because we're discussing data as it comes in, or maybe wanting to point out a correction that is needed, we might draw on it, make an export. If there's an area needed reviewing, pick a layout, file format, and export a copy of that to email to someone who may be working in the field. They could go look at the site, or maybe email it to Tony to use in a presentation. It takes just a second to generate, then we can see that map output. Okay. Simple, efficient tool. That's a big part of why we've chosen this software as a service technology for these types of projects, is they simply work and they help us get our work done. In a second, I'm going to show you how to build a dashboard really quickly. So I won't go into this for the sake of time today. And I'll switch gears here and we'll talk about collecting data, and we'll go through a quick demo on how to collect data, how to build a data collection app. So if you're in the first webinar, you heard a little bit about Survey 123. And Survey 123 is the application that we use on mobile devices to collect data. It does work both in places without cell phone coverage, which is very important. There's two ways of loading the app on a phone or on a computer. So it can be loaded through a traditional web browser, or it can be loaded through an app you would download through the App Store, whether that's an iPhone or an Android phone. When you do that, one of the advantages are you can download base maps, which is a crucial factor in helping ensure that when you're in the field and collecting data, that the data you're collecting is located in the right position and the attributes are correct. Survey 123 is a XML-based smart form technology. It's similar to the Kobo forms that you may use if you work within ADB, or the Google ODK is based on similar technology. The advantage for this is it's tightly integrated with other web mapping tools we use, as well as the desktop software programs of ArcGIS Pro. So once we build one of these forms, which we'll go into, you can load those data into a professional GIS software. You can make a large format cartographic map, or you could do robust analyses within the software using a live data set sitting in its data warehouse on the internet. So I'll spend a little bit of time demoing it, but before I do that, I'll share with you a few more thoughts about how Survey 123 works, just so you have some understanding of why this technology enables us to accomplish the kind of complex workload that we do when we're doing a BBA. So Survey 123 allows us to design the questions through a graphical user interface with a drag and drop interface. We can drag a map or a date collection form field. It allows us to see the answers online with pre-populated graphics. We'll look at a few of those, and then to visualize it in the ArcGIS Online web mapping interface. Importantly, built into Survey 123 is integration into a hub and a portal ecosystem where there's a tremendous amount of functionality to allow you to control access to information. So once raw data are collected, we may only want to share certain components of that information with different team members or to the public. And our hub website for this webinar actually is a good example, because we had folks fill out a form. About 50 of you have filled out our survey to share with us your background and experience, which has allowed us to tailor this content to you. However, we don't show all the information online. So what you have shared is kept private. And by the way, we'll delete that information after the webinar is over. This next slide was shown in the first webinar. It's an attempt to give you a broad understanding of how WebGIS works and the architecture. So at the bottom, with ArcGIS's online software as a service, there are GIS servers connected to the internet that warehouse the data. And the big advantage of this tool is the online portal, which helps us manage users and permissions, helps us save data, publish it, and back it up. And then across the top, the apps is generally what most users see. It's accessing a web map via your desktop browser or a website or the software, or using the tools via your mobile device. The last thing I want to point out before we go into the demo is with Survey 123, you can turn your data into actions. You can put wheels on it, so to speak. And the technically this is referred to as webhooks, meaning once data is collected, you can trigger an event. So in our research project, for example, say we had a scenario where a tiger was killed on the road, and Tony and Karma wanted to be notified if we had a tiger hit on the road. This technology, this is a screen capture of the user interface, and it's so easy to use that we use it, in fact. So you can filter a data feed from Survey 123, and you can trigger it to send, in this case, an email via Gmail to a certain number of users, and maybe even store some of that same data into a Google spreadsheet. A really valuable tool, and this is one of the ways we start translating this data so that as a team, you don't only put data into the system and never get anything back, but you actually are interacting and working with this system and using it as you manage the project as it goes along. Okay, now we're going to switch to a demo, and we're going to quickly build a Survey 123 form to collect some roadkill data. Okay, so we're going to switch over to the Survey 123 website here, and we're going to start a new survey. This is the designer app online. And we're just going to quickly give it a title. Give it a tag so we can search for it within our content library. The library for this account is growing. So there's data sets, there's surveys, there's dashboards, all these things are published under the same account. So we tag it and classify it, and normally we give it maybe a nice detailed summary so that we can find that information and know what's there. So this is the interface for Survey 123. There is a more technical interface where you can add more functionality, but this is more than sufficient for most needs. So Tony described some of the roadkill attributes and information we collect, and we'll just add in some of the most important aspects just to show you the ease of building a Survey 123 form. So we'll add a multiple choice question, and we'll call it species. And we can add the species list. And we can allow an other. Maybe our species list is incomplete, or we detected a new species in the area that we weren't anticipating. And we can make questions required. We can cache the answer, but that's not really appropriate here. So of course we need a species list. Next is a date. We'll add a date and we'll call it date observed. And we set a default value. We'll also make this required. Okay, And the last two we'll add here, we'll quickly add a location, a map. So we'll add a map. We will collect a point. We could also collect lines or polygons, which might be appropriate for some types of surveys. Maybe there's erosion occurring alongside a road, or maybe there's a zone where there's reptiles and amphibians alongside the highway, and you want to digitize the entire extent of where that species occurs. So in some cases, a line might be more relevant than a point. We can choose the base map. Here, if you go into more detail building this, you can build your own base maps and publish them that. You can ask the user for their location when they open the app by default. And again, we can make it required. The last element I will add to this is an image. So we'll give the user opportunity to attach a photo to the record. And they can browse their images on their camera or use their image in their photo folder. They had taken a photo earlier. And we won't make that required. All right, so we'll preview this. Here's very quickly, in about 5 minutes, what our data entry form looks like. Species, date, location, and an image. These are kind of the key criteria that we use when creating a roadkill survey. We can publish this online. While that's publishing, down here in the bottom right, you'll notice there's a modify schema button. The schema is, as you build this data entry form, essentially it's designing a database for you. The database being different than a spreadsheet in that some of the columns have a defined type of information that can be stored in them. So a date, maybe some coordinates, and in this case, a link to an attached photo. So once the information is published, we could share it. If you would like, you can take a photo right now of this QR code and access this data entry form. However, first, I need to share it with you. So right now, now it's accessible. And when you open it at the moment, it will open in your browser directly. However, if you took a photo of the QR code with your phone and you had the app installed, it would give you the option of open it in the browser on your phone or in the app. And again, the app, the advantage there's several. One being the base maps. The other being that you can start filling out some of the data and save it as a draft and complete it later. Okay. So that's creating a data entry form. And to answer one of the questions that's come up earlier in chat, have we shared some of these tools more nationally, maybe the Roadkill app for all of Nepal? That's a good question, because these tools can just sit there and they can be available to anyone. And I think we're going to discuss with the project team on our Nepal work whether or not we try to make that app publicly available and allow it to persist in the future. Okay, so we're going to switch back to our presentation now. And move on. So we've demonstrated how to build a data collection app. And now we're going to talk about dashboards. Dashboards, as the title of the slide says, there are ways to synthesize information. They're typically read-only. They are an integration of spatial information, in our case, with infographics, with interactive figures and charts, simple information. In our case, we often want to add in the ability to drill down. Many of us over the last year have gotten familiar with dashboards created with the same technology. The coronavirus dashboard published by Johns Hopkins is a great example. It does allow you to drill down to look at the coronavirus cases in different regions of the world and to understand how that had changed over the past year. So we're quickly going to create a dashboard right now, about 10 minutes. So hang on, we're going back in. Maybe before I do so, I may stop for a second and see if there are any questions.
So you have one more exercise to show, is it, Ben?
Yes, yes.
Okay, well, we could take a quick break for questions because there are a couple of questions. And I think there was a question which my colleague Lisa had asked. Do the apps have the ability to work offline in remote areas? Very important question.
Yes, yes. So as long as you have a cell phone that has a GPS in it, it will work offline. And I think earlier I was describing that there's two aspects of the offline app that's a huge advantage for working in remote areas. One is the base maps are stored on the phone. They do have to be obviously downloaded before you go into an area without cell phone coverage, as well as the data set itself. So you have to open the app, choose a region to download the base maps and the data collection form itself. And in fact, for some of the projects we work on, you may choose to download more than one base map, particularly as we're driving along highways and things. It's nice to be able to navigate using maybe a topographic or street maps layer, and then also to be able to look at an air photo or a satellite layer. Okay, thank you. It's good to interact and have a few questions here before I keep moving
absolutely.
on.
So another question, and I think this is sort of related to your point on the I guess sharing the use of the app and applying it across, sort of applying it nationally. This is a question from my colleague Suva. If we want to add regional data in the tool, if it is available in vector or raster form, in case this kind of data is absent, such as surface hydrology or natural hazards, where can we get such data from? Who should we ask for such kind of data?
Okay, we'll cover a little bit more of this in module 3. And we did cover some of this in module 1. And I know module 1 was recorded. So you could refer to both of those. So I'm both saying come back again next week and also possibly review last week's webinar. But just very quickly, there's a host of places to look for data. In our exercises for this webinar, we guide you through how to find data using the ArcGIS Online's Living Atlas. And they're global, it's a global data sets. In the first webinar, we talked about those global data sets and how to access them. But one of the real practical tips I also provided was to essentially find authors who've done work or other researchers and contact them directly.
Mhm.
You may require a data sharing agreement or another collaborative agreement to share or find some data if it's not available online. But yeah, there's a couple different ways to find and access data.
Mhm.
Hopefully I answered your question.
Yes, that did. Thank you, Ben. And maybe we'll just take one more question before going back to your exercise. This question is from Anna. In terms of confidentiality, as to my understanding, these are hosted by the Esri cloud. Is there a contract needed with Esri, or is privacy ensured with the use of these apps?
Yeah, so because the data is stored on their servers, you do enter into a contract. So through the webinar, you'll notice on our website, we encourage you to sign up for a free public account. That enables you to learn about the software and learn how to use it. With a paid account, your data is kept private. One of the aspects of that here in Canada is the location of where the servers are. You can choose to restrict your data store to be within your country. At least we can do that here in Canada. The other option is to install the software, the ArcGIS online software, on your own servers. So you can purchase this entire ecosystem of software to install on a server within your organization. So if you're working for an organization that had high levels of security, that might be worth that additional cost and effort to install that internally.
Mhm.
That
Okay,
maybe
great.
Vaughn can speak to how that's related to SPADE in a few minutes.
Mhm.
Okay, getting back on track, just really quickly, we'll demonstrate how to design a dashboard before handing the talk over to Vaughn. So I share my screen again. And we'll go into ArcGIS Online here. This is an account. This is a hosted account, just like I was saying. It's a paid account, so you can create apps, you can create dashboards, publish your own data. Here at the top left, you have a drop-down box that shows you all the types of things you can create, clearly in addition to adding data. And when you add data, you can add both vector and raster data and control the sharing, whether that's within your organization or out to the public. Right now, what we're going to do is we're going to build a dashboard, and we're going to use the data that we've collected so far from this webinar's survey that maybe some of you filled out. We're going to give it a quick name, give it a tag, storage folder. You know, this, giving you this really quick demo, my goal here is simply to show you, once you have your data published and you begin to be familiar with the interface, how quickly it is to integrate this information, you know, because you can see the whole link of what I'm presenting, hopefully. Okay, so we're going to start our dashboard. We're going to start by adding a map. I'm going to add the map, the hosts and attendees map. We can add functionality settings, like so we can show the legend and layer visibility. We could allow someone to switch the base map, or we'll leave most of these as default for the sake of time, but just be aware that there's a great deal of interactivity and options that you could add to any dashboard. So here's our map. We'll add a few quick metrics here. So we'll look and see how many attendees have filled out the survey. We will, what do we want to do? Let's look and see what folks, how many folks use GIS software for work. Here. We'll add one more control here. Let's add a list. A list is a specific details. This is each user who filled out the survey, and we'll filter this list to something fun. Maybe what we'll do is we'll do this. So we asked the question, how amazing is Karma and her team for creating this webinar? And some of you actually gave her a 4. So we'll filter the list to the 4 folks who gave Karma a 4, and we'll organize this here a bit. Drag this one here instead. A little slower here. Okay, rearrange. And here is the basic dashboard. So we have some filtered data, some live real-time summary of that information in the form of a pie chart, and a map of the locations everyone shared with us of where you are across Asia and Europe, and even Tony and I over here in North America. Okay, that's a quick dashboard. Obviously, I hit save, and we could share that either internally or publicly. So that was very quick. And just switch over here and say, provide a little context as we switch to Bon, who's, I think, going to present to us about the SPADE, SPADE tool.
Yes, so before we shift to Bon, maybe just one question, Ben.
Okay.
This is from Resmi Baskaran. I'm not sure I understand the question clearly, but do we need to manually select the location or use the mobile device location mapper? So I guess when you're using the app, how
so
on the location?
Yeah, on the app, there's several different options. You can use the app's internal location to record your where you are. Say you're at the site and there's amphibians or there's roadkill. You can also move the location on the map, or you can type in coordinates, and the app gives you the option of typing in the coordinates in different formats. In our projects, we often use UTM coordinates because they're easier to write down and get in the computer correctly. So you have several options there.
Okay, so it's not like the app, because usually we also have Google Maps on the phone, so the app will not automatically pick up from there. We have to like enter the location.
So it will automatically pick up your location. As when we created our form just now, we had the option of checking a checkbox that says attempt to get the user's location by default. And so when you open it and click on the map, it will try to get your location as long as your phone is location enabled and have a clear view of the sky.
Right.
So yes, it will find your location, but then you can adjust it. You could move it. Say maybe you saw the animal off to the side of the road and you wanted to shift it. You can do that either manually with your hand, or you can actually pick a azimuth, a direction, and a distance.
Right. Okay, great. Thank you, Ben. I hope we answered your question, Resmi. So now let's move on to Bon. Bon will be taking us through SPADE. This is a GIS platform, which is developed under an ADB project. And it also has a lot of spatial data and has the capacity for projects to source data as well as contribute data. So Bon, over to you.
All right. Thank you, Karma. I hope you could see my screen right now. Good.
Yes.
Good day, everyone. Good afternoon from Manila to start with. I'm Bon, and I'm the GIS focal slash administrator of this so-called web GIS platform that is available for ADB, which is SPADE, or Spatial Data Analysis Explorer. So it was really interesting, the presentation from modules 1 and Ben's presentation. He gave that overview and those how do you do this on ArcGIS. So what you will see right now is tools that are available now within the bank, within EDB, which you could already utilize for your project. So in the interest of time, I think I only have 10 minutes. So I will skip using slides. So I'll do a deep dive now on SPADE, do a live demonstration to you guys, because I will be showing two things. Number one is the SPADE platform, the web GIS portal that we have right now. And then the second one is the mobile app, which you could use for your mobile data, mobile collection. So you could use it in the field for your field data collection. So let me start with SPADE as the web GIS platform. So as you would see, I'll create a blinking circle right now. So it's like watching a YouTube training video. Okay, I hope you could see my blinking circle. So you would notice we're online right now, adb-spade.org. And then a quick, as I browse into this platform, just listen to me on a quick background. So for spades, development started 2017 and then deployed roughly third quarter of 2018. So in a nutshell, Spade has been operating for more than 3 years right now, and Spade started with um, uh, 2 pilot countries in 5 cities. But as you would see right now in this city search, you would see that there are different. We started with cities, but apparently the momentum is there right now. We have some projects, we have some screening tools, which I will go a deep dive later on. But what I'm trying to explain here is one of the objectives of a SPADE is have this central repository of geospatial analysis and data sets within the bank. So if you have let's say number one, you have a ongoing project right now. Let's say you already used some tools, and then you wanted a space or container wherein you wanted to have it placed for future analysis and for data sharing. You wanted to share it within your thematic sector or regional department. Then you could just provide the link to them and view that analysis or data set. So let me go. Let's say I'm thinking on top of my head right now. Let's say habitat. I'll, there. Um, I'll just click it. So this user interface right now provides you a screening tool wherein this is the natural and modified habitat screening layer. So is just the blinking circle now is on the legend. And then other layers that are available for this container, let's say this is a container, is I'll go to the layers available now. So you could switch from the natural modified habitat into critical habitat layer. So you could do your screening in here. So there you go. Sorry, my it seems there's a problem on my internet right now. There you go. So I hope you can see it real time right now. I'm basically changing the layers. I could zoom in, I could zoom out. Typical mapping GIS that you could do. You could zoom in interior area of interest, see if it's a likely or a potential habitat area, and then time check 225. So I'll show you other layers that are available in SPADE in terms of global data sets. You would notice that I have several um, um, platforms, or should I say sites, that is open right now. So you could open multiple SPADE platforms. So if you're working with different data sets, different analysis, you could open multiple instances of SPADE. So in here, I just wanted to show you that um, for other sectors, there's the land cover, there's the night lights data. You have flood risk in terms of CCDRM. You have water stress. So there are as I've mentioned a while ago, the momentum is now there to utilize SPADE within the bank. So from the biodiversity context, let me do a quick map right now. So what I'll do right now is, let's say you have those different data sets, that screening tool. You're interested to see what is the affected in terms of, let's say, biodiversity area. Let's say for this one, I'm uh, follow the blinking circle, elephant conflict. So I wanted to see, let's say, let's bring in the global biodiversity areas, a global data set. And then I think this is the latest one, April 2021 data set. So it's now in SPADE. So you would notice I could bring into this map several layers that is available in SPADE. I could also bring in the natural modified layer that I've shown a while ago. Uh, Typical GIS, I could adjust the opacity, and then while the training was ongoing, I added some layers in here. So for example, just to show you guys the catalog or the library within SPADE, there's 1,200 plus layers that are available right now. So just to show to you guys quickly how I add this one. So let's say I wanted to add the key biodiversity area. Just typing in KBA, it would automatically search the layers available in SPADE, and it provides you a quick background on what dataset is. In this case, it shows you in terms of vector format, in the polygons and the points. So I just added it in here. Just click the add to map. Then I added in here. And then let's say I wanted to add the natural modified. I will just type in habitat, and it would automatically search our database within SPADE. So it just click this one. So that's how you bring your data sets within SPADE. So in here you would see that in terms of, let's say, I'll turn some of the layers off. You would see that in terms of these elephant conflicts, the number of animals there, some are located on the biodiversity key biodiversity areas. And if you just uh, click a point, it would show you the data sets that are present for that point. So I'll wrap this up to 29. So well, for the WebGIS platform. So basically, there is already available GIS tool for ADB staff and consultants that you could utilize for your project. And jumping in now to the mobile platform, there's another one, the mobile the mobile application. I haven't bumped yet into the use of it in terms of environment and biodiversity, but in a nutshell, it's like the survey 123 that Ben presented. But in this one, I'll be showing you in terms of sanitation, they've used it in the field. This is in Baguio. They went into the field, do a house-to-house survey. You just needed your mobile phone, stand in front of the house, conduct that interview, and the mobile app would automatically get your position. You could take some pictures, and then if I click this point, it would show you the questionnaires that were utilized for that survey. So in a nutshell, for this mobile app for this mobile app that is available for ADB, we could tweak it in a sense that let's say you have your own questionnaire, then you could put in that questionnaire inside that um, mobile app. So let's say in terms of roadkill, in terms of animals, so you could have that questionnaire inside that mobile application, then go into the field and use it offline. So you could use it offline, online, but you would need that connection, that internet connection, to submit it in the cloud and have it in Spade. So let's say internet is not available within the area. So what you could do is open the mobile app, go into the field, do your field data collection, and once you go into your house or into the office, connect your mobile app to the internet, and then you could upload your data set, and then or download it now and upload it again to Spade. So that's the different. Time check to 31, so I have to wrap it up. In general, what I presented is the available tools that ADB staff and consultants that in terms of a GIS that you could utilize for your projects right now. So everything is open source. The Spade platform is open source. The mobile data app is open source, so we don't have any licensing issue in terms of, let's say, number of users. So let's say you wanted you have a team of 10 or 20, then you could just contact me, and then we could provide that number of users that you need, provide them the user accounts, and then you could utilize already the available tool. So that's it for me. Thank you, everyone. If you have questions, you could just send an email to me. Thank you, guys. Thank you, Harma.
Thank you, Bon. That's very useful. We have a question. How do we log into Spade? From Nicholas.
Yeah. Thank you, Nicola. So quickly, since Spade is at the moment available for ADB staff and consultants, so you would need to request for that account. So you could just send an email to let's say send an email to me, or spadehelp.adb.org. Then I could provide you an access to Spade. And if needed, I could quickly provide a Spade 101 to you, Nicholas. Thank you.
Thank you, Bon. So if I understood correctly, Bon, the data, the source of the data that is added to Spade is open source, as well as data from ADB projects. Am I correct? Bon?
Yes, yeah, sorry. That's spot on, Karma. So within Spade, whether it's coming from institutions, agencies, global data sets, or it's coming from the field, or coming from local governments, we have to realize the fact that there are sensitivities within data sets. So in a nutshell, we could provide that restrictive access so there are differential accesses within datasets. So let's say within your team, you don't want to share, for example, you go into the field, you have this sensitive data, then you could restrict that access within your members at the moment. But let's say in the future you wanted to provide access to anyone, then we could do that within SPADE. So there are different layers of access within the platform.
Mhm. And then if I may just make an overall comment in relation to the tools that the exercise that Ben took us through, and then what you showed us on SPADE, and how these two platforms add up. So I think from what Ben showed us, that is more like the front end where we are doing data collection and then putting it together. And then after we have created our data maps based on the data collection, then SPADE is where we can, it's like our library of data where we can store it in there, and it's meant to become this massive database for ADB projects, or even like global database for new ADB projects to refer to. Am I correct? Ben, you can also please
Right.
help to clarify this.
Yes, yes. Thank you, Karma. So yes. In let me put a hat of different projects within ADB. So what's happening now is you're utilizing, the projects are utilizing their preferred platforms, tools. So what SPADE is offering is SPADE could be an add-on to this platform wherein after you do this, as you've mentioned, you do this data collection, you have all these data sets, you could host it or have it in SPADE, so you could have this data sets within SPADE and also share it within your regional department or thematic sector. And if I may add, you could also use it. Let's say you're starting a project, you're still in the concept stage, and you don't have any consultants available or any tools that you could utilize your hands into. So SPADE could also be utilized in that sense, wherein let's say you wanted to do a screening for the area screening for your area of interest. So you could go inside SPADE, look whether there are available data sets. Let's say you wanted, as I've done a while ago, you wanted to do a screening in terms of natural and modified or key biodiversity areas. Then you could still utilize SPADE at the let's say at the concept stage, or even at the startup or even the implementation of the project. So it's not an or thing. It's really it's a mix. If you wanted SPADE to be an add-on value, then you could use it. But let's say you still don't have that data sets or tools that are available, then you could also utilize SPADE. That's as SPADE is as an open source tool. You could utilize it right off the bat.
Mhm. Right. So it's pretty flexible than this tool, and hopefully, I mean, it looks like there is already momentum in using this. So hopefully, it will really become this big, massive data platform for all of ADB. Ben, Tony, would you like to add to this point about the linkages with what you demonstrated and what Bon presented on SPADE?
Thank
Ben?
you for presenting, Bon. You did a great job. It's good to see an internal tool being used. It's good to see folks accessing information and using GIS. Clearly there are different capabilities of the two systems, and some of the information can be integrated. And I think that is a key point is using the tool for what you need and being able to access the data you need and keep it secure. Mm-hmm. Yeah, thank you for your presentation, Bon.
Mm-hmm. Thank you, Bon. So we have a couple more questions, and anyway, now it's the Q&A time. But maybe one more thing I'll ask you, Ben, with the specific experience with the Nepal project that you demonstrated. just to give our audience a feel of how this works in reality. So could you share a bit of your experience with the Nepal project? And Tony had mentioned that there were like field staff based in Chitwan, like in the site. Then there was another, the ecological expert based in Kathmandu, and you guys based in Canada, and Clara in Portugal. So in terms of the, I guess you would have needed to do some kind of a training. Did the field staff who were collecting the data with the Roadkill app, were they already familiar with this? Did you have to train them? And, you know, how easy was it for them to just, you know, grasp how to use the tool and start loading the data into the platform? Could you share your experience on that part?
Yes, yes. There was, to answer your question in short, for the field app, for the Survey 123 forms, there was almost no training done. We did get a few questions. They're the obvious questions. But due to the QR codes and loading the tools, other than your standard kind of training for field data collection that we're all familiar with, of, you know, what are the must-have aspects of any data set, you know, the key criteria. Yeah, the tool itself wasn't a hurdle to the users. And what was clear was, you know, whether it was myself or Tony or Bhuvan, some of our local technicians, they understood how to use it kind of just natively. So, you know, we're all benefiting from the common interface and design of, you know, Android phones and iPhones. So, so that worked very seamlessly. The website itself and editing the data for our team, that all required some coordination and communication. So yes, we had a training session to help everyone understand, yes, you can put the data on here and it's secure. You know, we have a lot of data on the website, both sensitive species, you know, protected species like rhinoceros and tiger, and their locations and photos. So, you know, all that being accessible was a great asset for everyone to be able to see the data as it came in, and understand how to download it for their own needs. You know, in our website, we use some of the camera trap photos for reports, for graphics to help folks connect with the data we've collected. Yeah, great. Hopefully I answered your question.
Yes, you did. And that's great to know that it seems that it was fairly easy and straightforward to get the team started with the data collection and using the platform. Okay, so if we can go back to our Q&A chat box, we have a couple of questions waiting for us. Tony, can I invite you to take some of these questions?
Sure.
This, from my colleague Suva. In case during operation, even after designing the project with specific features like underpasses, if the number of roadkill still increases, how do we design the post-operation mitigation measure? How should the scope of the survey be designed? So yeah, what if we got it all wrong and, you know, we had put the underpasses in the wrong places? Then how do we fix it afterwards?
Yeah, that really speaks to the importance of the post-construction monitoring. Oftentimes, you know, there's the work that's done pre-construction to determine where the mitigation should take place and how to design the mitigation, and then post-construction, nothing's done. But it's extremely important to be able to monitor how effective or what the performance is of these mitigation measures. And typically in these type of projects, if you do that monitoring and you do it well, you know, you tend to have an idea of where these defects lie and how you might be able to correct them. I mean, nothing is certain, but you know, those are sort of clues and information that can help you guide any sort of retrofitting maybe the fence wasn't long enough. If you were using some guiding fencing, if the structure is perhaps too small and your camera monitoring shows that animals come up to it, but they don't go through. But perhaps maybe there's another underpass not too far away that animals are coming up and they're going through, then that suggests that the smaller underpass or something about the design of that other underpass isn't effective. And it's a little bit more difficult everywhere in the world to have governments go in and tear up a highway and put in a whole new underpass, or maybe an overpass where there was a ineffective underpass. But the most important lesson we can learn from these type of post-construction monitoring and performance evaluation is that information can help you guide future projects.
Mhm.
And that's done by, not just publishing in the scientific literature, but also reporting, ADB reports about how effective, like what's going on in Bhutan right now, what will be going on in Bangladesh on those projects, how effective those different underpasses are for elephants. That information from those reports will help guide the design and planning of future underpasses and overpasses for elephants throughout their range. So it's extremely important to be able to monitor that, to actually go in and tear up the highway and put in a different structure. Sometimes that might be possible. Oftentimes it isn't, because the funds are expended and there's nothing left, but at least we have the information on how to do better in the future.
Right. So the post-construction monitoring is key. It's very
important. Yeah.
So another question from Rama. How did you determine the spot where to put the CCTV? So I assume it means the camera trap. Did you conduct a study before, or was it recommended by the local government? So the location on where to place the camera traps.
The camera traps, we knew more or less the distance from the highway that we wanted to put the camera traps, and the exact location, we left that to the field technicians. Myself and Clara and to some extent even Bhuvan, our Nepalese ecologist who's working with us. The field technicians that we have working with us in Nepal have much more experience selecting the exact location where to put those cameras, because they've been involved in the national tiger surveys that have, the 3 or 4 different surveys that have been done. But the actual location was based on what they selected, but the general vicinity was based on this criteria of having the cameras at a certain distance from the road.
Mm-hmm. Yes, and I guess their criteria for selecting where to put the camera is based on their knowledge and the information from the local communities on where generally there are sightings of wildlife species, right?
Generally, it's on trails. I mean, they try to locate. In fact, we went out with them and we try to locate within a 50 or 100 meter radius, where we can pick up animal trails or tracks in that area, and then try to find the best location to put the camera. Mm-hmm. And then there's other factors that determine, you have to clear the area from the vegetation and make sure that there's a good field of view and those sort of things. Yeah.
Right.
The local experience is extremely important in selecting those locations.
Yes, absolutely. And there's a question from Yayan, and this is, since the road is already constructed, the NHP road is already there, that's correct. Can you give an example of how the findings from this monitoring survey will be used as a reference for mitigation actions for the road? So
okay, how the data is going to actually be used to inform the mitigation recommendations, I guess, right, is the question. Mm-hmm. I could talk a long time about that, but I guess simply, we're using the roadkill data, we're using the connectivity modeling, we're using the species distribution information that we're collecting from roadkills and also the camera trap monitoring. But primarily the connectivity modeling is going to tell us where the most important habitat corridors are across the highway. And I think I mentioned it in the first module is that we essentially come up with a lot of different habitat corridors across that NHP road. Some are extremely important, which we call primary corridors, like the Barandabar. And then others are let's call them secondary of importance. And so based on the species of concern, the intactness of habitat, whether it's a large scale corridor or a small scale corridor, the constructability. Also, oftentimes we visit those sites, we visit these locations, which we call candidate locations for mitigation. And then from the site visits, we have this information about how important they are based on the connectivity, roadkill, and how well the land is secured in terms of conservation, and also constructibility. I mean, some of these sites are, and so we have basically 4 or 5 different criteria. We score them from 1 to 5, and this gives us an idea of what are the primary and the secondary and even tertiary corridors. And from that we can start designing or coming up with recommendations for the most effective design. And in primary corridors, that's oftentimes overpasses or big flyovers, the most expensive, the most effective structures. Tunnels, tunnels and flyovers are really the best that you can do, because it keeps the habitat intact. And we do that because we can't invest the same amount of money in all of these corridors, but we know that there's some that really require important investments.
Mm-hmm. Right. So then I'll just have one more question for Tony, and then 2 questions for Ben and Bon on the data aspects before we move to closing. So this question, Tony, is what challenges were encountered in the camera trap data collection, and did it have an impact on the quality of data?
Oh, there's always challenges with camera trapping data. Sometimes the batteries fail, sometimes the cameras fail, sometimes there's vandalism. Those are the typical challenges. We had one of the challenges we had was the pandemic. It basically, we had to stop camera trap monitoring because the field techs, couldn't leave, couldn't go outside. But we were able to recuperate or recover those sampling periods, and also that sampling season. I believe it was the wet season that we didn't, or maybe no, it was the end of the dry season, I think, that we missed, and we were able to extend it later on in the year. So those are some of the issues that normally you have to deal with is vandalism, cameras that may not be working. But we actually had quite good success, and we didn't have very many cameras that were defective, and I don't recall any that were actually stolen. I think maybe one might have been stolen, but we had budgeted for that. I think we ordered 30 cameras, knowing that if we could put out 22 or 23, we'd have some backups in case we lost some.
Mm-hmm. Yes, yeah. So we always need to have that backup budget. And in our Bangladesh project, we are actually hiring local community to guard the cameras, to check on the cameras from time to time. So, yeah. Okay, so question for Ben, and actually it's even Tony, Ben, Bon, all of you, from my colleague Duncan, about ADB is getting asked about contributing data from projects to GBIF. AFT have the data for nature publication, and do you guys have a feeling about this? What's your view on this? And what do you think ADB should do about our data? So this is more about the overall data project.
I'm not familiar with data for nature, the publication, or this is maybe a spatial data set, like Bon had showed, I think, some of the important biodiversity areas.
Yeah, so Ben or Bon, would you have a view on this? Are you familiar with data for nature?
Thank you, Karma, and thank you, Duncan. This is really an interesting question because this is just my opinion. So it would be in the long-term direction for ADB, it would be really good to contribute data sets coming from our projects, but apparently right, because right now we still don't have that central database wherein we could discuss which data sets or which field that we could share to other institutions or other publications. So hopefully this could be part of our objectives, because right now we have this newly created GIS working group. So hopefully this could be discussed in the coming months as part of the task or that we could do for in terms of the data sets within the bank. So short answer. Thank you. Thank you.
Right. I think we could do better in managing our data in ADB. So, okay, one last question, and we have, before we close, just one last question, and I'm not sure if you're familiar, but this is a comment from Jose, that there is this toolbox called the COBO toolbox, which has been utilized by both ADB and the World Bank, and specifically in Timor-Leste, where the resettlement team is using this for completing the resettlement action plan. So are any of you familiar with the COBO toolbox?
Yes, the COBO toolbox is both used internally in ADB. You know, it's the same technology as Google's ODK, Open Development Kit, and the Survey 123 that we just demoed. You know, all these tools offer these amazing advantages of being able to collect data efficiently, to build customized forms that allow you to get the data you need into the app quickly. To the prior question, with little training, because they're in intuitive interfaces to use. So yeah, you know, I think Bon and I both would highly encourage you to use these tools. You know, they do speed up information sharing, and as well the quality of the data you get at the end. Yeah.
Right. Okay, great. So, and I think Jose wants to have further discussion on this with Bon. So please feel free to, I'm not sure whether you have Bon's email address. If not, please feel free to send an email to us, the organizers, if you need to get in touch with Bon. So with that, I think we've answered all the questions, and we are just a couple of minutes behind time. And I think we should move to closing now, since it's almost 2 hours since we started. And I would like to invite Uni, Miss Uni Jong. She's the Senior Digital Technology Specialist with the Digital Technology for Development Unit in SDCC in ADB. Uni is a digital technology public policy professional with nearly 20 years of international experience. Before joining ADB, Uni was the Director of Public and Regulatory Affairs with the Telenor Group, a global mobile operator, where she led the advisory and stakeholder engagement on policy and regulatory issues related to telecommunications, emerging digital technologies, and data governance in Asia. Previously, Uni has led several research and policy analysis projects on digital economy, internet ecosystem, e-commerce, cloud computing, and data privacy and cybersecurity as a senior consultant of the World Bank and as director of research and consulting with TRPC, which is an advisory firm. Uni has a master's degree in international development policy from Duke University as a foreign language and area studies scholar, and her bachelor's from Ateneo de Manila University of the Philippines. Oh, interesting. Welcome, Uni. So over to you for giving the closing remarks.
Thank you, Karma. And I'd first like to congratulate the organizers and the resource persons for a really thorough and informative training session. I've only attended today's module, but I'm already walking away with a lot of valuable insights and ideas for future projects. And of course, I'm very honored and delighted to share some views to conclude today's session. So as the resource persons have iterated, the world's ecosystem face multitudes of threats, including habitat loss, overexploitation, invasive species, climate change, and gathering that evidence via primary data collection, within a formal study setting is expensive and time-consuming, if not impractical. And we've all learned during the pandemic that it could also be impossible. So therefore, there's no better time than now to ramp up our understanding and capabilities to use digital tools and data and make them really key cornerstone to understand the dynamics of environmental change and to map out pathways towards sustainability. So with that, I'd like to propose 3 high-level considerations, hopefully to complement today's excellent training. First, data project is a journey. There's high potential, but then the process can be often messy. Right? In the digital field, we often use 3 V's to describe big data, 3 V vectors: volume, velocity, and variety, which some of you, if not all of you, have heard in the past. Volume referring to the amount of data, variety referring to the different types, velocity referring to the speed of data generation and transfer. I'd like to offer 2 other V's that may be of value when you are thinking of your own data projects. One is veracity and value. So veracity refers to the importance of quality data and then the level of trust in the data sources. And value refers to the return of investment. In other words, the efforts and the process that go into discovering value from large and unstructured data sets, it should provide you with a positive return or outcome. And this last element is particularly important when you're talking about this current trends towards using unstructured data, such as Earth observation or even social media scraper, that to complement the formal data sets that a lot of our projects have already collected. These unstructured data are large and relatively cheap to collect, and they have enormous potential, but they can be messy, and trying to make sense of them and trying to use them can incur costs, which can be hidden at the outset. So it's important that we consider and identify what the objectives are, what the skill sets that are available, and then the incentives of the data collectors and then people involved to ensure that the information that's collected, it has quality, and we have the right investment to unlock the right potential. And as part of this effort, our team, the Digital Technology for Development Unit, we have ongoing partnership with European Space Agency, Japan Aerospace Exploration Agency, and also has a technical assistance in place to support different pipeline projects as well as DMCs to make sense of Earth observation data. And as a resource person mentioned, our unit also runs the newly created GIS working group and are looking at a long-term solution to collect and collate data that's generated within ADB. And I really look forward to sharing the insights that were shared today and continuing the dialogue with the resource persons as well as environmental group who are the organizers of today's training. Secondly, I'd like to stress the importance of embedding digital connectivity. The options of digital tools that can be used in the field is often the function of the digital connectivity options and the bandwidth that's available. And mobile apps are a great tool, but if there's more bandwidth and more connectivity options available, I think there could be more tools that can be used to make the data collection smarter, as well as the analysis more robust. Therefore, we need to do better and more in boosting the digital connectivity across the region. And one of the things that our team has been advocating, especially when it comes to linear infrastructure project, is a co-deployment of connectivity options such as fiber or towers alongside infrastructure projects. And of course, those elements have different ecological implications outside of just infrastructure, but we would like to still advocate that digital connectivity for its potential to make infrastructure projects smarter, as well as helping make ecological conservation more rigorous. I would like to stress the importance of co-deployment of digital connectivity alongside infrastructure. Lastly, I'd like to stress that in any data projects would require a multidisciplinary collaboration. I think one of the biggest barriers when anybody thinks of data project is that we don't have the right skill set. We don't have a data scientist. But I do think that the way we think about data scientists is almost a unicorn. You know, every skill set that the data scientist entails, the technical, the domain skills, and the experience, it's very difficult to exist in a single person. And a successful data project would require a combination of different types of professionals, someone who can make sense of data, someone with the right technical skills, but also people with the right domain skills, right? Someone who understands environment, someone who understands infrastructure, someone who can translate and what that means in terms of a project design. So in other words, that we need to integrate and collaborate more across different disciplines to make an ambitious objective such as environmental conservation work. And I see a lot of room for different teams within ADB, as well as in the government, to break silos and collaborate. So in conclusion, congratulations to the participants on embarking a really exciting a journey. And as the famous saying goes, we like to go far, go together. So thank you very much for this opportunity to deliver a closing.
Thank you, Uni. Some very useful insights there. And yes, we all need to work as a team and try to match our different skill sets and make the projects move forward by combining all our skills. So with that, we will close module 2. Thank you so much to all our resource persons. Thank you very much to Uni, to Shani, and to all our participants again for the excellent questions. So it was, I think it was quite fun interacting with you and answering all the questions. And we will be sharing the recording of this module 2 together with the recording of module 1 for all participants that attended today. And we hope to see you in module 3, which will be next week on Tuesday. So thank you everybody, and have a good evening, good day, and good night to Ben and Tony. Bye-bye.